Good afternoon. We're live again on YouTube. We're recording, and like I said, I'm gonna just focus on the page because I find that there's so much things to do in terms of the for this particular topic. So let's get started right away, starting on page 6. I know it's been a while, so I'm gonna probably do a little bit of a recap of what happened or what we did before the break. So when we started this trigonometry unit, we talked about angles in a standard position. So standard position always starts at the positive x-axis, that's your initial arm, and then it can rotate counterclockwise. That makes a positive angle, or counterclockwise makes a negative angle. So we have all of these are on your blog, right? It's on the blog, so you can go and check it out. So 23 degrees, that falls in because it's positive, it's counterclockwise, it's falling at or stopping at quadrant 1. Okay, so that's that piece that we did. And then we did this one. And basically we can figure out the coterminal angles to figure out the rest of the angles that has the same terminal arm. Given this formula, we're going to use this later on. Okay, so I'm going to refer to that later. Theta plus 360 times k. K is how many times you've rotated. K is a positive integer or a negative integer. That's what the z is all about. Okay, so all of these are on your notes. So what we're going to do is we're going to start off with this. I'm finding that there's not much place in here for us to write. So what I'm going to do is, as I'm going through this one, I'm going to take a piece of paper and write everything on here. Okay? So, review of the reference angles. Now, this reference angle was first discussed or introduced to you when you were in grade 11 pre-cal. So you talked about standard angle, and then the other one is the reference angle. And what is a reference angle? Let's read it first so that we know what the reference angle is. It says here, for an angle in standard position, we know what that means already, right? The acute angle, which are less than 90 degrees, angle between the terminal arm, and the x-axis is called the reference angle. And I'm going to introduce that, show you that right away. Any angle that is greater than 90 has a corresponding reference angle. This means the reference angles denoted by theta r are always positive and less than 90 degrees. And we'll see that. Like sometimes this definition is quite vague at this time, but when we look at different examples, we're going to see what that really means. So let's take a look at example 3. So this is page 6, example 3. Determine the reference angle, so theta r. I don't know, maybe I've gotten used to theta r being an uppercase, but it could be lowercase. So the angle in standard position is 95 degrees. This is the angle in standard position. Okay. Since it's a positive, it's going to rotate counterclockwise. You know, I like the visual. I like visualizing what I'm doing, right? Especially when we're starting out. So if this is 95 degrees, this is 0, this is 90, this is 180, this is 270, and then go all the way back is 0. And these are all in degrees. I'm going to refer this as degrees, and I have to make sure that I write down the unit, because later on we're going to use a slightly different way of expressing an angle. Okay, we won't talk about that right now. So where does 95 degrees going to land? Quadrant 2. So if this is 0, this is your initial arm, right? And it's going to turn 95 degrees. So 95 degrees somewhere there, right? So initial arm at 0, rotating this way, and this is where your terminal arm is. And theta is 95 degrees. Theta is 95 degrees. Now, if this is the angle in standard position, what is the reference angle? Reference angle is the angle between the terminal arm and the x-axis. Okay, so which one is that? That's this one. So I'm going to call it theta r. Well, how big is theta r? How can we figure that out? It's going to be theta r is equals to 180 minus, minus 95. So theta r is equals to 85 degrees. Okay? So far so good. So angle, the reference angle is the angle between the terminal arm and the x-axis. So where's the x-axis? What angle are in the x-axis? Angles along the x-axis are which one? This is the x-axis, so it's 0 and 180, right? 0 degrees and 180 degrees.
So when we're referring to a reference angle, it wouldn't be a negative?
No, no. It's going to be always a positive angle, right? Any angle that's greater than 90 will have a corresponding angle, and the angle, reference angle, is always positive and less than 90 degrees. Okay, good. So we got a visual that goes along with this. Let's take a look at letter B. Yeah, so why don't you go ahead and figure out where 227 degrees is going to land, like where the terminal arm is going to be. So which quadrant will the terminal arm going to be located at? Quadrant 3, right? So this is initial arm, right? And then it's going to rotate, and it's going to be somewhere around here in quadrant 3. So the angle in standard position will be from initial arm along the positive x-axis going this way. Theta is equals to 227 degrees. Now we want to know what the reference angle is. What is the reference angle? It's between the terminal arm and the x-axis. So where would that be? This is the terminal arm. This is the x-axis. That's this part. right? So theta r. So how can we figure out theta r?
227 subtract 1.
That's right. That's right. So theta r is equals to, you went all the way down to here, 227. And if we just subtract the 180 from that, we're going to end up with a reference angle. So 227 minus 180, we got a 47 degrees. There. So theta r is 47 degrees. So far so good? Yeah? Let's go 38 degrees, negative 38 degrees. Now what happens when our angle is negative? It goes clockwise, right? Yeah, so this is 0. Now, if we go clockwise, and this becomes negative 90 degrees, this one would be negative 180, negative 270, and then it would be negative 360 degrees. So where would the negative 38 degrees go? Quadrant 4. So this is our initial arm. Initial arm, that's where you're starting with, and then you're going rotating 38 degrees, but clockwise rather, this way. So it's going to be theta equals a negative 38 degrees. Now, what's the reference angle? 38 degrees as well. So, how can we, so theta r is going to be 38 degrees, right? And the reference angle, I'm trying to repeat myself because when we're using the terminology over and over again, this idea gets cemented in our brain. So reference angle is the angle between the terminal arm and the x-axis. Now we wouldn't go terminal arm here and then this is the x-axis, right? Because we said the terminal, if this is a terminal arm, the reference angle has to be less than 90 degrees. So far so good? Everyone's okay? These are building blocks. We're going to see this over and over again. Later. No, it's positive because it says here, reference angles denoted by theta r has to be always positive and less than 90. Positive. Okay. Good. Let's do D and E. Now D is kind of weird, isn't it? How can we possibly rotate 655 degrees when we can only go one rotation as 360? So what's happening there? That's going to be more than one rotation, right? So how would we figure this out? So 600, I think I showed this to you last time. If we do long division, so 655 divided by 360, you're going to have one full rotation. 1 times 360. Okay, so 1 times 360 is 360 minus 360 is going to be 295. So that means one full rotation, and then it doesn't stop there, it continues on for 295 degrees more, right? So what does that look like? I like to visualize what I do, because when you visualize what you do, it makes sense. So this is my initial arm, at positive x-axis. Okay, I'm gonna do one full rotation. I'm gonna do one full rotation. Should have brought like a little stick or something. And then I'm not gonna stop there. I'm gonna keep continuing on until I get 295. So again, plus a 295 degrees. So this 0, 90, 180, 270, 295 would be somewhere around here. So how do I show that I went around once and a bit more? I gotta go like this. One, that's one full round, and a little bit more. Like that. So our theta is equal to angle in standard position is equals to 655 degrees. Theta r is here. Okay, so how can we figure out the theta r?
Two full rotations would be 720. So you take 720, subtract 655.
Okay, you could do that, yeah. Two full rotation could be 720 and then minus 295. Yeah, that's perfect. I didn't even think about that. Any other idea?
Wouldn't it be 655? Say you know, subtract the bar.
Hmm?
Wouldn't it be 655 that you subtract the 720 bar off
720? Yeah. So you have to subtract that and then another 295 you can, right? Any idea? Anything else?
You could just count how many up it is there.
Yeah, you can do how many up, how many more do I need, because up to here is 295, not counting the full rotation. And then how many more do I need to get up to 360? Okay, yeah, that's a good one. Those are fine strategies, and there's nothing wrong with that. You have good strategies, and this is, if I were to do this, okay, that doesn't mean mine is always, you know, it's gonna be right, because yours is equally right. So this is how I did it. Okay, I know that the reference angle is always between terminal arm and a reference angle. Terminal arm and the x-axis. So the x-axis, if I do full, which is basically what your classmate said here, that will give me the 360, okay? And then if I take away the 295, 65 degrees. $65 degrees. Okay. Would the other ideas work? Yeah, so could we go one of your fellow classmate here said you go 720, that's a full 2 rotation, and then you subtracted 360 and a 36 and then 295, right? That would work. 655. Oh, 650. Yeah, or you can go 655. Yeah, same thing. That's a possibility too. Awesome. You're perfectly good. Okay, last for this one, negative 263. Visualize it first. Where is it? And figure out where theta r is, reference angle. Hmm? Mm-hmm. Yeah. You're asking me about this? Okay. Why does it work like this? Yes, yeah, that's right. Minus minus. It will make it a positive, right? Okay. Now, what's your strategy? How did you figure this out?
I just took 263 minus 180, gave me the
Mm-hmm. 263 minus 180, okay. And you put the negative to the other angle instead of the negative 263. Okay, that's good.
like I know that it was going to be positive, so I guess
Mm-hmm. Yeah, that's okay.
You know where the negative is,
You know where the negative is, okay. Any other idea?
I said like you can make
7
no.
missing from the 90, so you just take away the 7 from the 90.
Mm-hmm. Okay. Oh, you're thinking about this one here. This is 90 degrees right there, right? Yeah. Okay. Yeah. Okay. Can you hear different ideas in here? Now, this is my idea. Now, I'm gonna write down what I have in here. So theta r is equals to, this is what I usually do. I take the big angle minus a small angle. Okay. Now, which one's the big angle? Negative 180 or negative 263? Negative, which one's the big angle? Negative 180, right? Because negative 263 is lower than 180. So it's a big angle minus smaller angle is 83. Let's try it if that works for every single one. 360, so that's a complete, minus my smallest one. That works, right? So you have different strategies in figuring out your reference angle. Okay. Okay. Now let's take a look at example 4. Determine all angles. Now, determine all angles between 0 and 360 that have the same reference angle. Okay. Determine all the angles between 0 and 360 that share the same reference angle. Okay. Well, is this a reference angle? No, it can't be, right? Why not? What's wrong with this? Because it's over 90 degrees. You can't have a reference angle over 90 degrees. So this is an angle in standard position. So this is example 4. Okay, so 150 can't be a reference angle. So, well, what's the reference angle for this? 30. It's going to be like this. This is 150. Your reference angle is 30 degrees. Very nice. Okay, now what we're going to do is we're going to try to figure out all angles that have the same reference angle. So here's, if this is a reference angle of 30, then that means this is 30 degrees, right? 30 degrees, should make it all the same. Okay, so this is a 30-degree reference angle in quadrant 1. Is everybody okay? Now this is a 30 degrees reference angle in quadrant 2. This is 30 degrees reference angle in quadrant 3. It's quadrant 4. Now we're looking for all of the angles that will have that same reference angle. So in quadrant 1, okay, theta is equals to 30 degrees, right? In quadrant 2, what would it be? 150, okay, 150. Is everybody okay with that?
which is our original question.
Which is our original one, right? Because if you go from here, that's a 30. If you go from here to here, that's 130. Now what about in quadrant 3? And what's that? 210. So that's going to be 180 plus 30, 210. And in quadrant 4, it's going to be 330 degrees. Okay. So if it's in quadrant 1, theta is equals to theta r. Okay. I think this is what we discussed. If you took the grade 11 pre-cal, this is probably what you had. Theta and theta equal to theta r if it's in quadrant 1. So that's the easy part. Now if it's in quadrant 2, theta is equals to 180 minus theta r, right? Because 180, and then you took away the 30 degrees. In quadrant 3, it's going to be 180 plus theta r. That's how we got 210, right? Because we went, how did we figure that out? We went 180 and then a 30 degree more, 210. And then last in quadrant 4, what did we do? How did we get 330? 360 minus 30, which was your theta r. Okay.
And when we're showing the answer, do we just need to list what the total angles are, or do you want us to show it in terms of like theta equals 180?
Oh, showing your work in here?
Yeah, do you
Yeah.
want it like that as,
No, I'm just writing down generally how we would be. But
Oh.
yeah. This is easy enough. We can actually figure this out on our own without doing this. But I'm just showing you that this is what the formula is basically. Okay, let's take a look at letter B. 265 degrees. Well, this can't be a reference angle. It's too big, more than 90 degrees. So 265, see what that looks like. So it's just okay. So theta is equals to 265. So what's theta r? 85. Okay, so theta r. So theta r equals to 85 degrees. So now we're looking for all angles that have a reference angle of 85 degrees. Okay. So 85, I'm going to make it look like 85 degrees. Reference angle 85 degrees in quadrant 1. Quadrant 2. Okay. So what's the theta in quadrant 1? That one is 85, right? Because theta r and theta are equal in quadrant 1. In quadrant 2, it's going to be 180 minus 85, 95 degrees. In quadrant 3, is 180 plus 85, 265. And finally in quadrant 4, it's going to be 360 minus 85. 275 degrees. Is that okay? So far so good? Any questions here? You okay? Let's do letter C. Ooh, negative. Could this be a reference angle? It's deceiving, yeah, except for the fact that it's being negative. So the answer would be no, right? Because reference angle has to be positive and less than 90. Okay, so have your visual. Figure out where that is.
But where it is, if it wasn't like, if we were thinking about it, positive, like it was counterclockwise. So you're thinking, because then it'd be 345. Like negative 15 is the same as 345 if you go counterclockwise.
Oh, like here? So this is going to be theta would be negative 15 degrees.
But if you were to think about it, if it had been counterclockwise, it'd be the same as 345.
Yeah, 345. Yeah, we will figure that out right away. Yeah. Okay, so what do you think the reference angle is? Theta r is equals to 15 degrees. Okay, so we have to figure out all of the angles between 0 to 360 that has the same reference angle. So let's make reference angle in quadrant 1. And then they said the angle has to be in within 0 to 360, right? This negative angle that they gave us is just a way for us to figure out the reference angle. Okay, so we want the reference angle between 0 and 360 degrees. Okay. So in quadrant 1, theta is equals to 15 degrees. In quadrant 2, theta would be 180 minus 15. In quadrant 3, it's going to be 180 plus 15. And finally, quadrant 4 is theta 360 minus 15. And this is what you were talking about. Okay, good? Yeah.
Why are you going back into standard position if it's negative?
Which one are you asking about? The last one?
Well, all of them. Aren't you going in standard position? Because quadrant 1 is 15, quadrant 2, like... Because if it's asking for negative 15, wouldn't you be working on the negative rotation?
No, they said that determine all the angles between 0 and 360, not negative 360. Is that good? So we just needed that negative angle in here. That just tells us, it's trying to help us figure out the reference angle for that. Okay, let's do letters D. Oh, D is easy. Can you do D without graphing? Okay. Good. Did you get 6, 174, 186, and 354? Last but not the least, 308. So for question letter E, the angle in standard position is 308. So therefore the reference angle is 52 degrees. So if we want to do all of the angles that has 52-degree reference angle, it's going to be 52 degrees in quadrant 1. And that's going to be 128. Quadrant 4, 360 minus 52, which is 308 degrees. Okay. These little steps that we're doing in here, it looks like, oh, it's pretty easy. We want to make sure that we really understand this. We want to visualize it so that later on we can just use it, right? Good. Now, got into unit circle. Now, unit circle, what is a unit circle? A unit circle is a circle that has a radius of 1 unit. So a point P with the coordinates x and y, we don't know what x and y is, lies on a terminal arm of an angle in standard position. If the point lies 1 unit from the origin, we can use the Pythagorean theorem to relate the radius of a circle in the coordinate P. Now, this is really not, we didn't discuss this, but the formula for a circle, or equation for a circle is x squared plus y squared equals to r squared. That's the general formula of x of the circle. X squared plus y squared equals to r squared. What's happening there is that this circle, the description of this circle is that the center is located at 0, 0 with radius r units. That's what it means. So the radius is r, the center at 0, 0. Now, let's see. You don't have to draw this. I'm just going to show it to you, okay? Because there's not going to be a lot of room for you to do work in here, but just to show you what this looks like. We can have a circle that has a radius 5, can we? Can we have a circle with radius 5? Yes, right? Can we have a circle that's radius 10? Yeah. Can we have a circle with radius 1? Yeah, we can. So it's basically, if this is radius 5, radius 1 would be like that. Okay. Now within these, let's talk about this big circle first. Within this circle, in this circle, you can have a point x, y, right there. So that means it's x. What is this point in here? It's x, positive x, right, and then up y units. That's where the point is. And then this would be your radius. Now, this point could be over there too, right? Now, instead of radius r, its radius is 1. Okay? So sometimes we're looking for the x value and the y value and the r so that we can create the trig ratio that we're going to see right away. Okay? So here, it's going to be x squared plus y squared equals to 1 squared. The radius is 1. So when your radius is 1 and you square that 1, it's going to be x squared plus y squared equals to 1, which makes sense. So this equation of the circle has a center of 0, 0 and radius 1, known as unit circle. You've seen this last. This is what it looks like. So if this is theta, then this point here on the circle is x to the right, y up. Okay, so something like this we've probably done in grade 10. I'm sure we did. Some of you were with me. How can we figure out x or cos theta? Cos theta is adjacent over the hypotenuse, right? So adjacent. Adjacent is theta, x. What's the hypotenuse? 1. So when we say cos theta equals to x over 1, cos theta is just the x coordinate. Okay. What about the sine? Sine is opposite over the hypotenuse. So when we do sine theta, opposite is y, hypotenuse is 1. Because hypotenuse is your radius of that circle. And tangent theta is equal to opposite over adjacent. Opposite is y over x. So using this unit circle, cos of theta is really the x coordinate. Sine of theta is equal to the y coordinate, and then the tan of theta is going to be y over x. Okay, so that kind of, so if we replace, instead of x and y on this unit circle, okay, notice here, it's xy, and then over here, it's just cos theta, because x is equals to cos theta. Do you see that? And then the y here, y is equals to sine theta. So instead of x and y, it's cos theta, sine theta. Okay, now we've gotten used to the SOHCAHTOA, sine, cosine, and tangent. Now we're going to introduce the other trig ratio, which is a reciprocal function, right? So reciprocal trig ratios. The reciprocal, well, hold on. What does reciprocal mean? Oh, okay. In what way? The numerator, denominator switches, right? So the reciprocal of cos theta is secant theta. So it's 1 over x. Reciprocal of sine theta is cosecant. Cosecant theta is 1 over y. And reciprocal of tan is x over y. Now I'm going to rewrite it in a different way, okay? And this will become probably, we're going to see this again, it's called trig identities. So secant theta is equals to 1 over x. Well, wait a second, what is x again? X is cos, so 1 over cos theta. Yes? Now, what about cosecant theta? Cosecant theta is 1 over y. Well, wait a second. What is y? Sine. So it's going to be 1 over sine theta. Okay. And then cotangent is x divided by y. So that would be cos theta over sine theta. We'll see this later when we prove trig identities. Okay? So these are the reciprocal of the 3 basic trigonometric functions that we know. So, the coordinates of the points in a unit circle can be used to identify trigonometric ratios of angles terminating in quadrant 1. So we can also identify the trig ratios of angles terminating in other quadrants using our knowledge of reference angle. So let's see here. Terminal arm for angle theta. Okay. Determine the exact values of the sine trig ratio, 6 trig ratios for theta, if the terminal arm of an angle theta in standard position passes through the point 1, 4. So what does this tells us? 1, 4 is our xy, right? Okay, our xy. So where's 1, 4? Let's start with the visual first. When you see visually, it's better. So 1, 4. So 1, 2, 3, 4. That's our point P. Okay. What is our 6 trigonometric ratios for this? Yeah, and then the other ones, right? I'm going to put a circle around this because we were going to relate it to the unit circle anyway. Okay. Do we know what the R is?
4.
So this is 1, 4. So if we remember our Pythagorean theorem, the radius would be our R. this one here, the radius is not 1. Right? This is, radius is more than 1. So what's the radius for this? Hmm? Yeah, that's right.
Square root of y squared plus x.
Mm-hmm. Okay, so all of you remember the Pythagorean theorem, right? So radius is equals to square root of x squared plus y squared. Mm-hmm. So this is going to give us, we're going to leave it as exact value. So 1 squared plus 4 squared, so r is equals to the square root of 1 plus 16, so r is the square root of 17. So radius is root of 17. Okay, so is this a unit circle? A unit circle has a radius 1. This has a radius more than 1. So it's okay. This is our theta, right? Our theta is here. Now, what's the cosine? Cosine theta is adjacent over hypotenuse. So adjacent is, what's the x? Adjacent is 1 over root of 17. Okay, root of 17. What's sine theta? It's going to be opposite over hypotenuse. How far up is that? 4 over root of 17. Yes? And then tangent of theta is equal to opposite over adjacent. So it's going to be 4 over 1, which is 4. Okay. Those are the 3 trig ratios. Now, where's the other 3? Because we need all 6. So secant theta. Okay, well, what's secant theta again? Secant is a reciprocal of what the cosine is. So what would that be? Square root of 17 over 1. Yeah. Yes, square root of 7. Yes, you can simplify this as square root of 17. I like doing this because it shows whoever's reading this later on. See what happened to the 1. Okay. Cosecant theta. Cosecant theta. Okay, cosecant theta is the reciprocal of sine theta. So what would that be? Root of 17 over 4. Excellent. And finally, cotangent theta. Reciprocal of tangent would be 1 over 4. Okay, good. That's it. We're going to finish this just to let you know. We're going to take a little bit of a break, 5 minutes, and then we're going to resume this next 2 pages. Okay?